Okay, this is homework number 3, and we'll do 3 and 4. These are very similar. These are some concepts on sectioning, a little bit different than your offset and full sections and half sections. This one here, you have a base and you have a pipe, and these three things here are called ribs, R-I-B-S, and they're to stiffen the base to the tube. All right, they keep the tube in a vertical position, but they're just spotted in these ribs. There's one here, and by looking at it, there's 3 of them, and we can assume that they are 120 degrees apart because there's 3 of them in the 360, and they're in equal spaced. So when we cut through, see the cutting plane cuts through that to the center, then it cuts through that rib, and then the arrow is down looking here and looking here. So when we look at it over here, there's the diameter of the base, there's the tube coming up, and then there's this background of the rib, and I also have the background of the rib here. So I'm going to go ahead and darken in the whole perimeter, all the lines. It's pretty straightforward in this case. There's a little radius down in here, just a little one. A little radius there, and then there's the hole going through. Okay, and then I'll put the rib in. There's the silhouette of the rib in the background. And there's the silhouette of the rib on the background over in here. There's the edge, there's the other edge. Now, there it is. There's the rib. If I were to section, we cut through this. If I were to section the whole thing, that would not represent the true profile. The true profile is this little L here, and it's revolved 360, so you have the L on the other side. The rib does not get sectioned, even though the cutting plane goes through it. The cutting plane is going through it longitudinally, means the long direction, but we do not section it over here. So the section, again, I'll go 45 degrees. The section that would continue here. Okay, so there's that, and then we have the same thing on the bottom half, 45 degrees, equal spaced. Okay, so there's the finished product. This is one of those ANSI the ANSI standard for sectioning. And this rib is actually rotated down to the center line, then projected over. Because if you were to project it right here over, the rib would look so small. So we orientate it. It's revolved. That's why these are revolved features. We revolve it down to the center line and project it back over here, so it does show true size and shape. Again, the rib does not get sectioned, even though the cutting plane goes through it. Otherwise, it'd give a false representation of the profile. So the profile is actually this L, and these ribs are just spotted in 3 different places. Now, you've got the same concept down here. All right, we got 3 holes. They're on a bolt circle. A bolt circle is this diameter that they're all on. Okay, it's called a bolt circle. You can see that. That's center line, circular center line. It's called a bolt circle. Well, by looking at it, you can say, well, there's 3 of them, right? So we would assume they're 120 degrees apart. The first one's on the center line north, okay, at a 90-degree orientation right there, and the other 2 would be 120 degrees apart on that bolt circle, whatever it is. So when we cut through this hole, we're projecting it orthographically over here. That's why we're showing the hole here. All right. And then so the cutting plane comes through here. We're going to rotate the hole down imaginarily down to the center line here, and then we project it over so the center line would, so you have a constant bolt circle. So the distance from here, okay, I'm gonna take that radius should match this one down here, and it should match over there. So I'm gonna put a little mark there. I'll do it in black. So there's my center line. The reason we do this over here so we maintain the same bolt circle. The diameter of the bolt circle here should match, I'll just put BC for bolt circle, that should be this dimension here. Okay, that should match. That diameter here should match that circular diameter. If you would project this right from here, the hole would be back in here somewhere and it wouldn't show a true bolt circle diameter. So I'm going to go ahead and darken in. We need to section this as well. So I'll go ahead and darken in the whole perimeter. And then there's a little radius in there. Do the verticals. Since we're cutting through the hole becomes visible. And then you got these. This actually the top has been chamfered. That's why that exists there. Oh, let me go ahead and put the hole in. Just get the distance. Looks like it's there. And then be the same on the other side over there. So you got your hole down here, you got the hole up there, and then the rest of it is hatched. 45 degrees will go again, equal spaced. Okay, see this is not hatched because that has been countersunk. There's a countersink there, which represents that distance as a countersink. This hole is projected here. Okay. This hole has been rotated to the center line, then projected back over here, so it has true orthographic projection. And we maintain the same bolt circle here as we do here. Because look, as we're manufacturing this part, how are we going to look at it? We're going to look at it probably in this view here when we make it, because this is how it's going to look when it's on the lathe. Okay, yeah, we do have a top view as well that shows that it's round. Here, when we put dimensions on it later on, you know, in this course, we'll look at, you know, diameter symbols, etc. for dimensions. But this is the completed and correct view for number 4.